Good morning, Doctor everyone. My name is Liang and my matrix number is 277114. Today I wanted to go over question 1 from the assignment 5 of Introduction to Mathematical Economy. From question 1, part A, the question asks us to determine the concavity of a function fx equal to x cubed minus 6x squared plus 18x minus 15. So as we know that to find the concavity of a graph we have to use the second derivative. So we find the first derivative by differentiate the given function first. So we can got the first derivative, which is equal to 3x squared minus 12x plus 18. And we continue to differentiate it to the second derivative. And we got the answer of the second derivative is equal to 6x minus 12. At the stationary point, second derivative of the function is equal to 0. So we set the second derivative equal to 0. So 6x minus 12 is equal to 0 and 6x is equal to 12, x equal to 2. So we can know that the critical point of the function is 2. So now we plot this critical point on a number line and we create a sign chart. So now we plug in a number which is smaller than 2. Let's say x equal to 0. So the second derivative equal to 6 times with the 0 minus 12 equal to the negative 12, which is a negative answer. We also have to plug in a number which is greater than the 2. For example, I choose 10. So 6 times with the 10 minus with the 12 equal to 48. This is a positive answer. So when the value of x is smaller than 2, the second derivative is equal to negative, and since the value of the x is greater than 2, second derivative will form a positive answer. When the second derivative is smaller than 0, which is negative, so the graph will form a concave downward. And in contrast, if the second derivative is greater than 0, which is the number is positive value, it will form a concave upward graph. So we can conclude that from negative infinity to 2 is concave downward, and from 2 to infinity is concave upward. So we can get our graph like that. Let's see the next question. The question gives us a cost function which is the cx, which is equal to 0.000001 x cubed minus 0.003 x squared plus 5x plus 1000. For the first question, we have to find the marginal cost. We can find the marginal cost through the differentiation of the cost function. So the marginal cost of the cost function is equal to 0.000003 x squared minus 0.006x plus 5. Okay, this is the marginal cost function. For the part 2, we have to describe the behavior of the marginal cost function, whether it is concave outward or concave downward. So actually the method used in this question is almost the same with the solution in the part A. So we use the step as the part A. First of all, to determine the concavity, we have to find the second derivative. So we got the first derivative already, so we differentiate the first derivative and to become the second derivative. So we got a second derivative which is equal to 0.000006x minus 0.006. So at the stationary point, we have to set the second derivative equal to 0. So we can got the answer which is x equal to 1000. Okay, so 1000 is a critical point for the graph. So again, we plot this critical point on the number line and create a sign chart. Then we put in a number that is smaller than 1000, for example, negative 1000, and substitute in the second derivative, and we got the answer is the negative 0.012, which is the negative answer. And we also have to put in a number that is greater than 1000, and let's say it is 2000, and we got the answer is 3 over 500, which is the positive answer. So we can conclude that when x is greater than 1000, the second derivative of the cost function is positive, and when x is smaller than 1000, the second derivative is negative. So the concave downward of the cost function is between the negative infinity to 1000, and the concave upward of the function is 1000 to infinity. For the last question, part C, we need to find the level of production that will yield a maximum profit for the company. In this question, we got the revenue and cost function. As we know, profit is the difference between the revenue and cost. So we can use this method to find profit function. So the profit function is equal to revenue minus cost, which is 2x cubed plus 40x squared plus 8x minus with 3x cubed plus 19x squared plus 18x minus 800. Then we get the profit function is negative x cubed plus 21x squared minus 72x plus 800. For the level that yield a maximum profit is when the gradient of the profit function equal to 0. Also mean that the marginal profit equal to 0. So we need to find the marginal profit by differentiate the profit function. So after we differentiate the profit function, we got negative 3x squared plus 42x minus 72. At the maximum profit, marginal profit is equal to 0. So negative 3x squared plus 42x minus 72 is equal to 0. So we can use the factoring method to find the value of x, and we got two value of x, which is x equal to 2 or x equal to 12. So because we got two value of x, we have to use the second derivative of profit function to determine which is the level yield the maximum profit for the company. We differentiate again the first derivative to become the second derivative, and we got the second derivative is equal to negative 6x plus 42. So now we substitute the value of x into the second derivative. Since x is equal to 2, the second derivative is equal to negative 6 times with the 2 plus 42 is equal to 30, which is greater than 0. So this is the minimum point. And then we substitute 12 also into the second derivative. Second derivative equal to negative 6 times with the 12 plus 42 equal to negative 30, which is smaller than 0. So this is the maximum point. Therefore, we can conclude that the level of production that will yield a maximum profit for the company is 12. And then we're gonna to find the price per unit to maximize the profit. So we already got the revenue function. So in economy, we know that revenue is equal to price times with the quantity. In this question, the quantity is equal to x, so the revenue function is equal to px. So 2x cubed plus 40x squared plus 8x is equal to px. So when x is equal to maximum profit, which is 12, and we substitute the value into the function, finally we got the answer p equal to 776. So we can know that the price per unit to maximize the profit is equal to 776. Okay, that's all for the question 1. Thank you for your watching.